Great. So we want to go straight. Today's activity, we're going to go through this Neopon lesson. You want to pay attention, write down notes to help you remember. We're going to continue right from where we left off on Thursday. Because we couldn't finish on Thursday, we want to finish this before we go to a new topic on Tuesday because I want to make sure that I don't just dump stuff on you, but you're following along. Okay, so I hope that works for everyone. So you want to pay attention. We started with naming of compounds or chemical nomenclature, which is just naming, and we've been trying to understand the rules that guide how compounds are named. And we want to continue with a different set or a different class of compounds, which are called ionic hydrates. Okay, so we're looking at ionic hydrates. So if you're looking at ionic hydrates, you want to pay attention to the word hydrate. What makes something a hydrate? When we're saying a hydrate, it means it contains water molecules. Now we all know the chemical formula for water is H2O, that's water. So if you see a compound that has water in there, it's likely to be a hydrate. And most of all, what makes you sure of it being a hydrate is that the compound that follows the hydrate or the water molecule is likely to be ionic. So that's why it has the name ionic hydrate. So you're looking at compounds that are ionic compounds. Ionic compounds means that they're formed from one positive ion combined with a negative ion, a cation reacting with an anion, or a metal reacting with a non-metal. We spoke about all of that last week. So when I see a hydrate, for example, this is a hydrate. So we have a hydrate here. So what is the rule that governs hydrate? When you want to name a hydrate, first you need to identify if it's a hydrate. How do I know? It contains a water molecule as part of its main component. So this one contains a water molecule H2O, and normally you see this dot in the midst of it, this dot here. So normally most hydrates are ionic hydrates are going to look like this. So I have an ionic hydrate here. If I want to name this ionic hydrate, what are the what is the rules I need to go by? First thing, you're seeing that we're going to add a term to the name. Okay, so you're going to add a term to the name, and that term indicates the number of water molecules. Okay, so we are adding a term that will indicate the number of water molecules. So here you can see, let's look here. We have 5 water molecules. So we need a term that will indicate the number of water molecules. So we are just going to follow the same rule we had. So for normal ionic compounds, we said that we name the cation first, then we name the anion. So that rule is for ionic compound. But this time, because the ionic compound has a hydrate, we are going to add an extra term to the name. And the extra term will be what? A name or a term that identifies the number of water molecules we have. Right? Great, great. Then now this term we're adding, this term normally begins with a prefix, okay, a Greek prefix, and it ends with the word hydrate, okay. So the term you're going to add, it's just a Greek prefix that indicates the number of water molecules. So if there's one water molecule, you're going to use a Greek prefix that indicates one. 2 water molecules, you're going to use a Greek prefix that indicates two. 3 water molecules, you're going to use a Greek prefix that indicates three, and it goes on and on and on. Okay, so remember it's ionic, so you're going to follow the normal rules for ionic compounds. What is the normal rule for ionic compounds? We name the cation first, then followed by the anion. This time, because it's a hydrate, then we're going to add an extra term. This term begins with a Greek prefix. This Greek prefix is supposed to be telling you the number of water molecules you have. Then it ends with the word hydrate. Okay, So we're going to look at an example. An example is this term we have here, Cu. So this is our example. This is a ionic hydrate. We have CuSO4 dot 5H2O. This is our compound. We're going to try and follow the rule to be able to name this compound. Right. There's another example we have. We have Na2CO3 dot 10H2O. Okay. So we have another ionic hydrate here, right? And this ionic hydrate is solely this is an example of ionic hydrate. So we have two examples of ionic hydrate. We're going to use them as examples. But even before we move on, I want you to see this. So these are all the prefixes that you can find. So you need to write this down in your notes. Make sure you can remember it. We're saying that when it's 6, it's going to be hexa. 6 is going to be hexa. 7 is going to be hepta. 8 is going to be octa. 9 is going to be nona. 2 is going to be di. So if I have 2 water molecules, I'm going to have dihydrate. Alright, if I have 3, I'm going to have trihydrate. 4, I'm going to have tetrahydrate. 5, I'm going to have what? Pentahydrate. And it goes on and on and on. Okay. So let's try an example. We have CuSO4.5H2O. So first of all, I know I have 5H2O here. I have 5H2O. So which prefix do you think is going to go with the hydrate? 5. So I have 5 here. So we're thinking about penta. Okay, we're thinking about penta. So I know that the last part of my name for this compound is going to be pentahydrate. So I know that. I put that in my mind. I know I'm going to have the last part of the name to be what? Pentahydrate. So you see it. Now what about the first part of the name? The first part of the name is the ionic part of the name. And because it's ionic, we're just going to follow the ionic compound naming. And the ionic compound naming tells us that you name the cation first. So what is our cation? We have Cu, right? So Cu is our cation, and Cu stands for copper, right? So we write copper. Now the second part of the ionic compound is SO4. You can see that. So we have CuSO4. Now SO4 stands for what? Sulfate. So we have sulfate. But remember, copper is an example of a metal that has variable charge. If you remember last week we were learning, we said that some metals or some cations or some positive charges, they have more than one fixed charge. So copper has a variable charge. So we have copper 2. We have copper 2, Cu2 plus, and we have Cu3 plus. Okay. So in this case, we need to identify which copper we are dealing with. That is why we put this 2 here. And that tells you we're dealing with copper 2. So the whole name is going to be copper 2 pentahydrate. And that's our final name, copper 2 pentahydrate. Copper 2 pentahydrate. Okay, and that is going to be our name for this compound. It's going to be what? Copper 2 sulfate pentahydrate. Sorry. So copper 2 sulfate pentahydrate. Remember, we follow the ionic rule for naming the first part of this compound. The last part is a hydrate, so we're going to use the rule for hydrate, which says what? We're going to add a term to the name. This term ends with hydrate and it begins with a Greek prefix that tells you the number of water molecules. So if I have 5 water molecules, I'm going to have penta. So pentahydrate is going to end with pentahydrate. The first part is just going to be the name of the ionic compound. So copper 2 sulfate pentahydrate. Okay, so that is the rule that will govern this ionic hydrate naming. Great. Any questions? You want to write? If you need to write something down, you can pause this video. Write something down to help you remember. Okay, great. So we want to move on. So we want to just refresh everything you just heard right now. So anything you can remember, put it in the response box. Write everything you can remember from what we just discussed. Everything you can remember, put it in the response box here. It's just to help you remember. Anything you can remember from what we just learned, you write it in the response box for me. Okay, great. And we're going to go to the next part of this. The next part of this. The next part of this, you want to look at molecular compounds. Now remember, I told you another name for molecular compounds is what? Covalent. They're the same. So covalent bonds. If you remember from our last time we were studying, we said covalent bonds they deal with what? Sharing. So we're sharing electrons. In covalent bonds, we're sharing electrons. Just keep that in mind. So normally covalent bonds, we're going to have two non-metallic elements. Remember we said ionic compounds. One is a metal, the other one is a non-metal. In covalent, both of them are non-metals, which means both of them can be found on the farther right side of the periodic table. Normally for ionic compounds, one will be on the left, one will be on the right hand side of the periodic table. We're seeing with molecular compounds, all of them will be on the far right. They are all non-metallic, which means it's likely that most of them will be anions. It means that they are negatively charged. It's likely. Okay, great. So we're seeing for this kind of compound, the rule for naming is that we're going to do what? We're going to name the more metallic element first. So all that means is that even though most all of them are going to be found on the far right, the one that is more on the left than the other is going to be named first, right? So the one that is on the more left than the other. So for example, I have boron here and I have chlorine here. They form a compound and this compound has a name. We're saying that all of these two are all found on the right hand side. They are all non-metallic. But even though we're saying that both of these are all non-metallic, but one of them is more on the left than the other, and that is boron. So because boron is more on the left than chlorine, we're going to name boron first, followed by the name for this thing. So we're going to find out how to name it. So first thing, name the one that is more metallic first, or the one that is on the left and on the bottom of the periodic table first. We'll follow that name by the other one which is more on the far right, which is the one that is more non-metallic. And when we are naming that, we just change the ending of that name. We change the suffix of that name to "ite," right? After we change it to "ite," we begin it with a Greek prefix that tells us the number of atoms that is in that element. Okay, so we name the first one which is on the more left, or the one that is more metallic first. So we name this one first. Then we follow the name of this by the name for the element that is here, but we change the suffix of that element and we bring IDE. I bring IDE there. But after I bring IDE, I want to begin the name for this element with a Greek prefix that tells me how many elements I'm dealing with for this part of the compound. Okay, so let's try with this. I have boron. We all know B is boron, so I write the name of boron. Boron. Sorry, this is O. Boron. Oh wow. I have boron. This is R. Boron. Now this is chlorine, but the rule says that I should end the suffix with what? "ite." So I know I'm thinking of something like chloride. So instead of chlorine, I'm thinking of something like what? Chloride. I'm thinking of something like chloride. But they're saying that the beginning of this chloride should have a Greek prefix that tells me what, how many elements I'm dealing with for chlorine. So I'm dealing with 3 of chlorine. So I'm going to write tri. 3 of chlorine is going to be tri. So now the final name is going to be boron trichloride. It's going to be what? Boron. Then this is together, trichloride. And that's how we name them. The same rule. Boron trichloride. Boron trichloride. Do you get it? Remember, if you've forgotten the prefixes, look on this screen. All the prefixes are here: di, tri, tetra, penta, mono for one, and it goes on and on. Just so if you've forgotten. So for example, I I have IF7, right? I have IF7 here. IF7 like this. I have IF7 like this, right? Great. So I know first of all, we named the first one. The first one is iodine. So I know my first name. Oh, sorry. My first name is going to begin with iodine because I stands for iodine. The next thing following iodine is F. F stands for fluorine. So I know fluorine, but I have to change the suffix of fluorine. INE. I change it to IDE. So I know I'm dealing with something like fluoride because that's what the law says. The rule, sorry. Fluoride. Now I have to begin this fluoride with a Greek prefix that tells me how many fluorines I'm dealing with. I'm dealing with how many fluorines? Everybody look here. 7 fluorines. So based on my prefixes, it's going to be hexa. So I'm going to now put hexa here. Hexa. So now my name becomes what? Iodine hexafluoride. Oh, sorry. 7 is not hexa, sorry. 6 rather is hexa. 7 is hepta. So I change this hexa to hepta. Sorry about a P. So we all can spell hepta. PTA. Right? So instead of hexa, I have hepta. So iodine hexafluoride. If I change this to if I change the question to IF6, then it will be iodine hexafluoride. That is IF7. So iodine heptafluoride. And that is it for molecular compounds. Don't forget the rule. You follow the rule. So it all goes by the rules. By now, I'm expecting you to be writing your rule down. Okay. I'm expecting you to be writing your rule down. Okay. Great. So that is the rule for molecular components or covalent molecular compounds or covalent compounds is the same. Okay. So everything you can remember from what we just did, respond to it here. I need to respond to it here. Okay. Everything you can remember from what we just did, just respond to it here. So you're looking at the next group of compounds. They're called binary acids. They're called binary acids. We're looking at a certain group of compounds that are acids. How do we know they are acids? Binary acids. How do we know? Binary normally means two. It means they are just made of two elements. They're normally made of two elements, but they are acids. How do we know they are acids? We know they are acids when they are comprised with hydrogen and one other non-metallic element. We know that because anytime we see a hydrogen, when it's dissolved in water, it's going to release hydrogen ions, and that's why we know that it's going to be an acid. Because when we dissolve that compound in water, Normally, acids release hydrogen ions. So anything that has the capability to release hydrogen ions when dissolved in water, we say they are acids. Okay, and they normally have very high pH. We're going to deal with a topic in chemistry called acids, bases, and salts. When we get there, we're going to learn more about acids. Today, we're just learning about how to name them. So I have a compound. Let's say I have a compound with HF. This compound is a binary acid because I see hydrogen here. And I see a non-metallic element. Most non-metallic elements are on the far right. Fluorine is on the far right of the periodic table. So this is a binary acid. How do I name this binary acid? Okay, we're going to try two examples. Another example is also what we call HCl. These are acids. How do I know they're binary acid? I see H here and I see a non-metallic element. Chlorine is on the far right, just like fluorine. They are all on the far right. They are all on the same group. It means they are on the same column on the periodic table. That's what it means. So how do I name it? It says the first rule says this. The word hydrogen is changed to hydro. So I change hydrogen to hydro. So I'm going to start. Let's try this compound first. So the name of this compound, instead of saying hydrogen, I'm going to change it from. So the name of this compound, I see hydrogen and I see fluorine, right? If I want to name it as an acid, so it has a name as a gas. The name as a gas is hydrogen fluoride. That's its name as a gas. But I want to name it as a binary acid. If I want to name it as an acid, what I mean is that it has been dissolved in water. So when this gas is dissolved inside water, it becomes an acid. Why? Because it's going to release hydrogen ions. Okay, so we are thinking of it as dissolved in water. Now anything that is dissolved in water, you're normally going to see this symbol AQ. So anytime you see AQ written by a compound, what it means is that aqueous. Aqueous simply means dissolved in water. That is what it means, aqueous. Aqueous means dissolved in water. Okay, so how do I name this acid? We're saying that you change the hydrogen to hydro. So my name is going to start with hydro. Hydro. So the first rule, change the hydrogen to hydro. What is next? The other non-metallic. So look at rule number 2. The other non-metallic name is modified by adding IC to the suffix. So this is fluorine, but I'm going to change fluorine and change its suffix. The suffix is going to change from fluorine, INE, to IC. So I have fluorine. So hydro, fluorine is going to change to fluoric. So fluorine. So I change my fluorine to fluoric. Instead of INE, I'm going to have IC. So hydrofluoric. Then the last rule says that you just add the word acid. So I add the word acid. Just like that. So now I have what? Hydrofluoric acid. And that is it. Hydrofluoric acid. Just like that. Just like that, I have what? Hydrofluoric acid. So remember, change the hydrogen to hydro. The other non-metallic element, we change the suffix and add ICE. So fluorine becomes fluoric. Then now I add the word acid. And that is the name. Okay, so you see hydrofluoric acid. This becomes hydrochloric acid for here. So H changed to hydro, the same thing. I have hydro. Chlorine, INE becomes chloric. So chloric, hydrochloric. Chloric, hydrochloric. Then the acid becomes ACI. Then we have hydrochloric acid, and that goes for this. So by now, you're following the trend. Just follow the rules and you get it right. Great, great, great. So a quick one. I want you to try, without looking in your notes, try and write anything you can remember for what we've done. Just right before this slide. So write down anything you can remember, the rule, what you need to do. Just try and write it in this for me. Respond to that for me. Great. Now this is our last one. This is our last one. Oxy acids. So we're looking at something called oxy acids. Interesting. Now we're looking at a certain group of acids again. How do we know what an oxy acid is? You're saying that these compounds contain hydrogen, oxygen, and at least one other element. So normally an oxy acid is going to have what? Hydrogen, oxygen, and another element. And because of this composition of the compound, they normally have acidic properties. When we say something has acidic property, we're going to learn it as we get to acid, bases, and salt. But one of the properties of acid is that they have a pH. They have a certain pH range. I think previously I said they have a high pH. No, that's not right. They have a pH range. Anything that has a pH less than 7 is an acid normally. Anything that has a pH above 7 is a base. We're going to learn more about that. Don't worry. Normally, acids turn blue litmus paper red. You're going to learn more about that as we go on. But we're saying if you see a compound that normally has a hydrogen, oxygen, and another element, it's likely to be an oxy acid. And there's a way to name oxy acids. Okay. So let's say I have an oxy acid like H2CO3. That's an oxy acid. We're saying that the first rule, what is rule number one? Rule number one is omit hydrogen. So in the name, don't bring hydrogen. Forget about hydrogen. Pretend there's no hydrogen there in the name. So this is H2CO3. I'm going to omit the hydrogen. Fine. Rule number two says that start with the root name of the anion. Now in this compound, H is the cation. CO3 CO3 is the anion. It has a charge of -2. Now, who remembers the name of this anion CO3 2 minus? If you remember from what we learned previously, the name of this anion is carbonate. Carbonate. So if you are omitting the hydrogen, we're going to be left with only the anion, and the name of the anion is carbonate. So it says that start with the root name of the anion. So the root name of the anion is carbonate. So I know that my name is going to have something like carbonate. But rule number 3 is saying that replace the ATE with IC, or replace the ITE with OUS. So I have ATE, so I'm going to replace ATE with what? IC. The rule says that if it's ATE, replace it with ICE. So my name is going to sound like this: carbonic. So I'm going to have carbonic. Carbonic. So instead of carbonate, I'm going to have carbonic. Then the last thing is saying that add acid to the name. So I'm going to have carbonic acid. There you go. And that is my name, carbonic acid. And that's the name. What do we have? Carbonic acid. So the name becomes carbonic acid. And that same thing is going to apply to all of them. So this table gives you the name of the anions. So so for example, omit the hydrogen, you're going to be left with the anion. The name of this anion, C2H3O2, is called acetate. So the acid becomes acetic acid. HNO3 is an anion. It's called nitrate. If you omit the hydrogen, you are left with the anion. The anion is called nitrate. So the acid becomes nitric acid. NO2 is nitrite. We said that anytime you have an ITE, it changes and becomes what? OUS. So we're going to have nitrous acid. And it goes on and on and on. This is the rule for oxy acids. Okay, great. So you want to write down anything you can remember from this here. Okay, anything you can remember from this right here. Great. Now we already did our exit ticket the other time in class. Now I need you to answer this for me based on all we've learned from last week this week. Answer this for me. If you get each one correct, it's 1 point each. So respond to this for me. I'm going to grade this. Then you answer these for me too. I'm going to grade these too. Each. So read the instructions carefully. Answer this. I'm going to grade this too. And you already know. Please, the announcement is everything is in OpenStax. Don't forget, everything is in OpenStax. This was just to help us finish what we didn't finish last week. If you want more information, go and open the textbook. OpenStax, I've uploaded the textbook in Canvas. And please check Canvas for the rest of the week. Office hours. Please, if you know you're struggling with anything, I keep reminding you. Office hours, tutorials, Tuesdays and Thursdays. Please just come on the Zoom and let's go through whatever you're struggling with from 3 to 3:30. Great. Thank you so much for your time. And we'll meet on Tuesday for class. I hope you have a great rest of your week.